All right, so our next speaker is going to be Jim Jones. So he's from the Consumer Specialty Products Association, and he's going to talk about his experiences with the paradigm change in U.S. government science and regulatory decisions. Thank you.
Thanks, Christy. Well, that was a fascinating presentation. I could spend all day sitting, listening, and learning about that kind of information. So I'm with the Consumer Specialty Products Association, which is a Washington-based trade association that represents basically consumer-facing products companies. However, I'm going to be talking about my time at the Environmental Protection Agency, where I worked for 30 years, including the last 5 as the assistant administrator in the Office of Chemical Safety and Pollution Prevention. I'm a successor to Lynn Goldman, who was here yesterday. And I'm going to be talking about some of the non-science factors associated with integrating 21st century science into regulatory decision-making. And it's going to be very much a follow-on to the presentation that you had yesterday from Lynn Goldman and Stan Barone. They spent a lot of time talking about the science context of the endocrine disruptor screening program. I'm going to talk about some of the non-science factors that were important in EPA's decision to rely on some non-animal studies in its endocrine disruptor screening program. And I'm going to focus on the non-science issues because I am not a scientist. And I also think it's actually quite relevant to how government or any institution tries to figure out how to manage in this context. So I'll spend a little bit of time going over the context, but I'm going to rely mostly that you were listening closely yesterday to Lynn and Stan about the endocrine disruptor screening program. I'm not going to do a real deep dive into the program. And then I'm going to talk about some of the programmatic factors and some of the other factors that play into decisions an organization are made. It's fundamentally a managing change issue, and what those factors are. Some of them are organizational, some relate to skill mix, some relate to stakeholder involvement. You guys spent some time yesterday morning talking about issues associated with stakeholders and building trust, and some were just classic policy choices. And I don't think that these are factors that are at all unusual to the context that we were operating in. I frankly don't think they're really unusual to the topic of integrating 21st century science into regulatory decisions. I think they are relevant to any time an organization is trying to manage change. So just a little bit of a reminder. So as you heard yesterday, EPA spent about a decade developing assays that were required by the Food Quality Protection Act. After getting advice from a FACA, it was called the EDSP. Lynn talked about that a little bit yesterday. At the end of the day, this is around 2007 or thereabouts, we had 11 assays that defined the screen that EPA was going to rely on to require chemicals to be tested against. And the law required, as Stan described, that all pesticides needed to be screened against these assays. So that then pesticides were not distinguished between the active ingredient and the other chemicals that are included in that, usually referred to by EPA as inert ingredients. And EPA had also made a policy choice to run this screen for, to develop the screen for estrogen, androgen, and thyroid. Even though the statute only required it for estrogen, the agency made a policy choice to expand that to androgen and thyroid disruption. So you've got 10 years of work going into developing the science that will then be deployed. They included, I would call them medium throughput type of tests. They were not high throughput, but they were not classic, whole live animal, some of them were, 2-year bioassays. So I'd call them medium throughput assays for the assessment of endocrine effects of chemicals. The agency identified about 10,000 chemicals that it thought was appropriate to run through these screens. So we've got these assays now, and we then begin to issue orders. In April of 2009, EPA issued orders for the first 67 of these chemicals for the Tier 1 screen. This is the battery of 11 I just referred to. Data submitted and reviewed. That whole process takes about 4 years. And so there you are in about 2013, and you've now reviewed the data. Early in this process, so the agency actually asked this FACA in 1998, are high throughput screens adequate for this work? And in 1998, the response came back, no, they're just not robust enough. So the agency's looking at the beginning, can we do this through high-put screening? The advice back is no, they're just not robust enough. So the agency develops these they were not alternatives, they were alternatives to high-throughput screens, and now has them, but you begin to look at the numbers. It's going to take 4 years to run ultimately 50 chemicals because 15 of them dropped out, 50 chemicals through a screen. You get to run the test, review the data, do the math. You're talking about decades, possibly a century, before EPA is going to be able to screen the chemicals that it thinks are important for screening. Simultaneously, and this was a result of dialogue going on between program offices and EPA's Office of Research and Development. EPA's Office of Research and Development, which included multiple offices, but led by the National Center for Computational Toxicology, created the potential for some high throughput techniques to replace some of the EDSP assays, but not all of them. So in particular, and you've heard about this yesterday, some of the assays related to estrogen were actually quite far along by 2010, 2011. Androgen was getting close. You heard from Stan yesterday. Next week, the agency is going to have peer-reviewed some high-throughput screens as replacements for the androgen-related assays. So the question for EPA a couple of years ago is, do we continue on this path of 50 or so chemicals every 4 years, or do we switch courses and adopt a high-throughput approach, even though we actually don't have all the assays we need to adequately assess these chemicals? And if we do that, how do we manage this pivot? And pivot is the term that we described. And so I'm going to talk about how the agency managed that challenge and some of the, as I said, non-science factors in making those kinds of important choices. So a little more of the context, and you heard a little bit about, actually came up a lot yesterday, the idea of fit for purpose and problem formulation. I call this Jim's hierarchy of application only because it hasn't, this is sort of what I picked up over many years of talking to our scientists about the relative ease, if I can use the lay term, of applying these techniques to various types of questions. And it's critically important, as people said numerous times yesterday, to make sure you understand what is the problem that you're trying to solve, and that will help inform the level of rigor that you need to bring to the science. And you know, you can quibble with, and I'm sure there are different degrees within these 5 broad categories, but in my mind, prioritizing a bunch of things to me is one of the most basic things that can be done using these high throughput screens, these alternative testings. I also think, and I think the most complicated thing is actually used for risk assessment. And they're vastly different decisions. What to work on first is different from what's the risk of this chemical. They're actually also very important questions. When you've got 10,000 things to look at and it's going to take you a century to do it, deciding what to do first is actually quite important. Even if it's going to take you 10 years or 15 years, deciding what to do is actually a very important decision. It's different, though, from the decision of this chemical has this risk to this group of individuals. And they're just fundamentally different questions. And I think between them are a range of things. I think you actually, there are ways in which you can take these alternative tests and actually use them in conjunction with a classic whole animal study risk assessment. I think the toxics program at EPA has begun to do that, where it takes the classically performed risk assessment using whole animals and then looks at what came out of the high throughput screens in ToxCast and just characterizes that. Ultimately, I think this is actually a little harder than prioritizing, because you will confront eventually the scenario that was raised yesterday where the results don't totally line up, and that puts you in a position of having to interpret that. Then I actually think, and there hasn't been, you didn't hear much discussion about this yesterday, but I think that the science has developed enough, as a non-scientist, that you can actually begin to custom design a chemical data set. And by that I mean you actually can use these high throughput assays for a chemical that is not well characterized, say a chemical with no data, and use these screens to decide actually what data is it that I need to be done in whole animals to ensure that I am adequately protecting for any possible adverse outcomes. In that scenario, you're basically saying, I'm confident enough in negative results that I don't need this kind of data. Instead, I need that kind of data. And I think over time, we'll actually be able to help you inform exactly how that study should be. You don't rely on a standard guideline, but you actually have a customized guideline. I think that needs further development. Then there's a replacing. I'm actually going to replace a study, a non-high throughput study with a high throughput assay. And that's actually what we were going to try to do, which is sort of not my general MO, which is to start with the easiest thing. That's generally what I like to start with. We started with, I think, is one of the hardest things to do. And lastly, I think, is risk assessment. And so, and I'm sure, as I said, one can quibble about the relative difficulty of these, in what order they go in. And also, I think that there are variations within them, that these are not the only 5 kinds of questions one can ask as it relates to how you can use these high throughput tools to inform decision making. So let's talk about some of the organizational issues that were involved. You had multiple, as Stan described yesterday, which is one of the strengths, also is one of the challenges. We had multiple organizations with EPA working on this. The Office of Research and Development. You had 2 offices within the Chemical Safety Office, the Office Stan leads, the Office of Pesticide Programs, where you'll be hearing from Anna Lowett later on, each with different cultures, each with different objectives on how to implement the endocrine mandate. ORD, not surprisingly, focusing on cutting-edge research. The Office of Science Coordination and Policy had just spent, you had people who had spent 10 to 15 years developing a framework, and now we were asking them, we're not going to use that anymore. That was actually one of the most difficult aspects of it, and you can't find many people who are going to spend that much time on something who are just going to say, yeah, fine, that's, go ahead. And so that was actually quite a big challenge. They were very vested in the framework, completely a rational response. And then the pesticides program is a very deadline-oriented place. And they're like, we have to be done by 2022. I really don't care how good it is or how bad, as long as we can meet the deadline. I'm being a little bit facetious here, but just a very deadline-focused oriented organization, and trying to fuse together the evolving science with buy-in to an approach that was just created by a group of individuals and in other organizations. Like, I got a deadline, it's a statutory deadline. And frankly, I appreciate all of those perspectives. I think it's really important to have those perspectives in an organization, and trying to sort of manage through them all was a very interesting challenge. Every application of 21st century techniques are not going to have this exact organizational scenario, but I'm pretty sure you are going to have some elements of it. Because the techniques themselves are so relatively new, there's a reasonable likelihood that some elements of this you will confront as you try to deploy these technologies. But they will differ by organizations and by the nature of the issue that you're trying to integrate in. I think once again, I said, a little earlier that there are these really, 5 different ways that I've identified that you can bring the science into decision making. And my general MO is start easy, walk before you run. And in many ways, we did take on one of the more complicated parts of the hierarchy that also came with an organizational complication that made it tricky as well. Skill mix. This is, for a while, this is going to be an issue, I think, everywhere, because people who do this kind of work, who do hazard evaluation, exposure evaluation, risk evaluation, have relied on techniques that have been around for a very long time. People have become national and international experts in hazard, exposure, and risk using an approach that many government agencies have relied on. They are recognized by peers across agencies, within agencies. And now you're bringing in a new knowledge that is often the same background is often opens one up to being able to learn these things, but you do have to learn new things. And so that is something I think that everybody is going to confront who begins to deploy these techniques. And I think it's really important to just have your eyes wide open about that and to be able to help people manage through it with training and other appropriate means to ensure that that your highly skilled workforce doesn't come away feeling disheartened by the introduction of new techniques. And this doesn't just apply to the scientists, it also applies to the risk managers. That would be what I was, a generalist who had become reasonably facile with a model that to me is one of the reasons, and intuitively I knew we needed to move on, was like, if someone with my background could actually track reasonably well the old model, it couldn't have been that good. And I'm glad that I am now outside of government because I really, really can't understand the stuff you're doing now. So you had a whole bunch of risk managers who had become facile with low L's and no L's and margins of exposure and the low dose linear model and 10 to the minus this, that. And they are going to have to learn as well about a new science paradigm, how hazard and exposure are expressed in different ways. Stakeholders, which you guys spent a bunch of time yesterday talking about, and this is actually, I think, one of the things that EPA does pretty well. I think the Chemical Safety Office is actually quite good at it as well. And here the agency took a multiple different angles on this. One of them, and I thought was one of the most interesting and creative, was the ORD's National Computational Center for Computational Toxicology actually had this open house monthly call with anybody who is interested in working with the data could call. And so the data was accessible, and they would host this monthly call for stakeholders. And they went out of their way to make sure that there was diversity in the stakeholders. And so there was active recruitment of NGOs. Industry was very interested. Academia was naturally very interested. But they did that for a very long time, which I think was critical to expanding the community of practice. It is not really possible to do chemical assessment work, or certainly not regulatory work, if the stakeholders don't even know the basics of what you're doing. And this is different enough that a fair amount of energy needs to be put into ensuring that everybody taking ownership of ensuring that there's enough knowledge in the community broadly to actively engage. And I think that ORD's work there was pretty important. Then the Office of Chemical Safety and Pollution Prevention followed more traditional processes. Peer review, there were numerous peer reviews. Virtually every time we were ready to move to the next level, we took the science to our scientific advisory panel, which is a statutorily mandated peer review, statutorily created peer review that's managed out of OCSPP. The pesticides program has a policy FACA called the Pesticide Program Dialogue Committee that has a diverse group of stakeholders from manufacturers, public interest communities, academia, the public health community, multiple other federal agencies, states, some science, some generalists, and they regularly brought, and they meet that this FACA meets twice a year. They regularly brought updates of the science as it was evolving to that policy FACA, and then just classic notice and comment Federal Register notices that were then also posted on the web to get feedback when decisions were being made. So sort of more very traditional, but as you can see, the agency came at it from multiple angles. There wasn't just one effort made to bring stakeholders in to ensure that there was meaningful input and buy-in. Classic science ways, non-traditional science ways, and then some of the more traditional things that EPA does of just meeting with its stakeholders and then just take notes and comment. So then there were a bunch of policy choices that had to be made, and they were not particularly easy to do. When and how are we going to make this pivot? By June of 2015, we were comfortable that for just three of the 11 of these assays related to estrogen, that there could just be replacement. You would not need to run the medium throughput assays. So should we continue to issue orders? The order would go out and say, for the other 8, do the 8 medium throughput assays, but for the 3, you can use high throughput. Ultimately, EPA, that was me, decided not to continuing issuing orders because you were just going to basically do a lot of rework, but instead focus on the science development. And that's what I'm very glad to hear. That, I mean, that decision could still prove to be foolhardy, absolutely, but that EPA is close on the androgen endpoints is quite heartening. At that point, the agency will have almost half of the 11 assays can be addressed through high throughput means. Then I think the agency will have another interesting choice, because thyroid is much more difficult. And we knew in 2015, Stan was telling me, I'm only about 2 years away on androgen. And he apparently was right. That was not the answer to how far are you off on thyroid. That's much further down the road. And so I think that there's a big choice in front of the agency if it goes well next week on androgen. Do you wait on these thyroid high throughput, or do you go forward with this bifurcated? We'll use medium throughput for thyroid, we'll use high throughput for androgen and estrogen, and I think that will be an important decision point for the agency. Ultimately, we delayed screening of these chemicals because we think that in delaying and focusing on these 21st century techniques, we were ultimately going to be able to do it faster. And I still think that it is very much in play that EPA will save decades by that choice. Again, time will tell, because the traditional means it's incredibly slow. I would jokingly say, and I was always being disabused of this, that by Stan and Bob Kavlock and ORD and others, that well, we can either take a century or we could do it over the Memorial Day weekend. You choose. They would say it takes a little longer than the Memorial Day weekend, but that in a very sort of general sense, that's actually not an inaccurate statement. The office also figured out along the way, by bringing in ExpoCast, which we tend to spend more time on the hazard side than the exposure side, but ORD has also invested heavily on the exposure side, in particular in the last 6 years, and ExpoCast is the fabulous name of that, to match ToxCast. The agency now has determined that it actually can use the two to determine the order of screening these chemicals. So even if you can do it much more quickly, it's still important, the order in which you do things, because doing things more likely to be problematic early on is definitely more public health protective than doing them at the end. So in summary, there are a lot of non-technical factors that are important to manage when you're attempting to integrate new science into a regulatory process. I think that there are fewer of these non-science factors if you're approaching perhaps, for example, an issue like, I just want to figure out how to prioritize within my space. There's certainly opportunities to do that right now. I think there are fewer challenges, although I will tell you, so that question, so I'm just going to prioritize in my space. You'd think that would be like a no-brainer. My space, I don't have to work with anybody else, I'm just going to bring in well, bureaucrats are quite, they're always thinking ahead, they're trying to figure out, how am I going to get things done? It is pretty unlikely that you're going to meet a senior leader who hasn't already figured out what the priority system is going to be, and they already have it mapped out. And so I confronted that a couple of times when talking to some of my subordinates not in the endocrine space. I'm like, well, why don't we just use these tools to prioritize the first 10 chemicals we're going to do, for example, under phosphor reform. Jim, we already figured it out. We've already got, well, maybe this will be better. We've already figured it out. And so you will have some of these classic change issues, really, no matter how simple is your intervention going to be? Some of them, this one I think was particularly challenging because of the higher level tier of replacement involves than, for example, setting priorities, and that we were dealing with multiple organizations. Why, after 30 years of learning to walk before one runs, did I decide to run before really walking very well? And it was because the upside was so big that the potential for saving decades in screening chemicals to me seemed worth taking on a risk of doing something that there's a reasonable likelihood that you weren't going to run like your fastest time ever, and you might even trip, fall a couple times, but it seemed the upside was much bigger. I would not choose to do something as complicated unless you had a really, really significant upside. And then lastly, the senior level engagement is critical, and it's hard to put enough emphasis on that. You're going to be asking people to change in a very, very meaningful way. And that usually does not happen unless the senior level engagement throughout an organization to support that. So thank you very much.
Great, thank you. So we have about 5 minutes for questions.
Thanks, Jim, for a really interesting talk. I think I'm maybe the only surviving member of the EdStack in the room.
Now that Lynn's gone.
As such, I just wanted to correct the record a little on this because, as you know, at the beginning you said that the EdStack actually argued against high throughput screening, and the opposite is in fact true. And I pulled up the EdStack report on my computer just to remind myself, and in the executive summary it says, the EdStack recommends that some of the Tier 1 screening assays be conducted in a high-speed automated fashion to provide preliminary hormonal or biological activity information. This approach is called high-throughput pre-screening. Then goes on to describe what that is and define it, and then says such a process permits a large volume of chemicals to be tested in a short period of time. And then the EdStack goes on to recommend that high-throughput pre-screening be conducted on all chemicals with current production volumes greater than 10,000 pounds per year, all pesticide active ingredients and formulation inerts, and all chemicals that are proposed to bypass either Tier 1 screening or both Tier 1 screening and Tier 2 screening for any reason. So that was actually in the original report, and for many years there was an effort to validate these high throughput screens. I believe EPA deferred to a Japanese effort that was ongoing for many years that ultimately didn't really go much of anywhere. EPA didn't put a lot of energy into that at the time. And instead really focused a lot of effort on validating the medium throughput Tier 1 screening assays. I sort of feel a little frustrated because I feel like the recommendation was there, that sort of languished for a while. The most work was in the validation of the Tier 1 screenings. And then right as those finally were ready to go, and they were medium throughput assays, so it's not like they would have taken a century, they would have taken a week instead of maybe Memorial Day weekend. And then there was that pivot to go back to an original recommendation. So just sort of wanted to lay that out and get your thoughts on whether that really, that original idea, which then seems to be in ToxCast, using the ToxCast for the prioritization, maybe could have been started even sooner.
That's a great clarification, Gene. I appreciate that. So I was not in the decision-making role in that at that time, but my understanding is that the pre-screen was ultimately interpreted by the agency because it couldn't get enough robustness around it as the screen, using this effort with the Japanese, that it would provide prioritization as opposed to, so you would have done the high throughput to set priorities, but not to actually be the screen. And so that's why I use shorthand, that I should not have done so. Now, whether or not if the investment in the pre-screen as opposed to the medium throughput work, could have turned the pre-screen into the screen. That's a choice I can't evaluate whether that would have been the more rational thing to do or not. I don't know. None of which takes anything away from the fundamental point that I was trying to make, is how do you manage change in evolving science? There may have been a choice made that was not optimal 15 years ago.
So
Jennifer.
I'd like to just sort of follow
Oh,
up
sorry.
on that. Hang on. It's difficult to look at you and talk into that. Valerie Adams with the U.S. Army, and I speak for myself, make that clear. So what I kind of worry about, because what this makes me think of is when I was in grad school, I was at the University of Texas Health Science Center in San Antonio. We had chromosome 3 for the sequencing of the human genome, right? Human Genome Project. Think about where we are now, that you can send, you know, a swab from your cheek, right, out and get your own personal sequence back. So I worry about paralysis in moving forward simply because we are waiting for what that next great invention is that's going to shortcut us through all this hard work that we have to do. When in actuality, I think we still probably have to do some of the hard work, pick our easy projects and easy gains, easy wins as they come up, and kind of keep slugging away at those harder parts.
I don't disagree with that.
One more question? Do we have any other? This is just a follow-up question to Gina's, and I'm sorry if you actually answered it and I missed it. Do you think that that pre-screening recommendation would have been considered differently by the agency if NCCT had been up and running, like the ToxCast program? I'm trying to think about the timing between the ToxCast program and
I can't really answer that because I don't know whether it's a chicken egg kind of thing, whether it was it the failure of that gave energy to it? Was it the recognition that there really was an opportunity, or had the agency decided 10 years earlier to do something? I can't. I mean, it's certainly possible that had we had a ComTox center earlier, that you could have made the pivot earlier. That's not, but I don't know. There's Bill Farland. Okay. Thank you. Thanks.
Great.